Hello, everybody. My name is Zenith Tandukar, and I'm in the Anderson Lab at the University of Minnesota in Agronomy and Plant Genetics. And today I'll talk to you all about Penicus, a potential cash cover crop with major environmental and financial benefits. But what is Penicus? Penicus is a member of the Brassicaceae family and is related to rapeseed and canola. We like it because we have the ability to make rapid genetic improvements in Penicus due to its small genome size and simple genetics. It has very high oil content, as you can see, with 27 to 38% oil by weight and high erucic acid content with 30 to 40%. This makes it very suitable for biodiesel and jet fuels. It also has very high natural yields of 1,000 to 2,000 kgs per hectare. Now, my research at the University of Minnesota is focused on major productivity challenges in pennycress. What I would really like to do is understand the genetics of seed and pot size and oil content in pennycress. As you can see, the seeds of pennycress are tiny with 1,000 seed weight of only around 0.9 grams, which makes it really hard for farmers for mechanical handling. And since we want to use it as a biodiesel and jet fuel resource, we really want to maximize the oil content in pennycress. Now, I would like to go on and say that pennycress will not compete with any major food crops. It is grown in the off-season in terribly harsh conditions, and the high erucic acid and glucosinolates make the natural oil not good for human consumption. However, it is a great source for biofuels and jet fuels. But it will definitely provide many intensification benefits like increased yield or output per unit area. It'll allow us to diversify the crops on the landscape and provide many ecosystem benefits like nitrogen sequestration, pollinators, food source, etc. Now, our breeding goals at the University of Minnesota for pennycress and soybeans are interconnected. In a sense, we are trying to create high yielding and high oil pennycress for farmers. We are trying to develop intercropping studies with soybeans to facilitate sustainable agricultural intensification. We also want to contribute to the identification and development of soybean varieties specifically adapted to pennycress intercropping systems so we reduce any penalties on soybean while providing maximum pennycress yields. Now, how would it look? This is an aerial view of soybean pennycress intercropping study. And as you can see on the top left, it's soybeans without the pennycress intercrop. And you can see that the soybean is growing happily and healthily. On the top middle, you can see that there is a lot of yellow intermixed with the green. Those are the mature pennycress with soybeans coming through them. Now, what it would look like close up is the soybeans that have been planted into the pennycress are germinating and growing happily from within the pennycress, as you can see in the picture here. Now, what I would like to finish with is saying that current agricultural practices have room to add a second crop to optimize land use. This is important because these crops provide important ecosystem services like erosion control, nitrogen sequestration, pollinator feed source, and many more. Pennycress is being evaluated as a winter annual cash cover crop because it is a financially viable and a sustainable source for farmers. And my research at the University of Minnesota seeks to understand the genetic basis of seed size and oil content to create high yielding, high oil, and soybean complementary pennycress. With that, I would like to thank my advisory committee and my members and my mentor and my funding agencies. Thank you for your time.